This lesson is about inverse cumulative normal distribution, so lots of words. Pretty much what we're going to be doing is looking at finding a limiting value when we know the probability or the percentage. Okay, and we're going to break them up into three types of problems. One's where we know the left tail, the center, and the right tail. So I'll start with one of these left tail problems. We've got the mean height of 177. I know the standard deviation is 8. What should the minimum height for a ride be? What should be the minimum height so that 20% of the people can't ride it? So we've got a big queue of people lining up for a ride. We want to shorten the queue, so we're going to say the shortest 20% go away. We need to tell them what that height is. So essentially, there's some value here such that the shaded area below it, some value, say C, such that the probability that X is less than C is equal to 0.2. Okay, so in exams you won't have necessarily that diagram to refer to, so you'll draw your own diagram, just showing the random variable X, mark your mean of 177 and your standard deviation, some value C, mark that this is 0.2. We're trying to solve the probability that X is less than C is 0.2. So the way I'll do that is just straight using my graphics calculator in stat mode. After a distribution, it's a normal distribution, and instead of using NCD like normal, I'll use the inverse normal distribution. Okay, I've got three options: left, right, and center. What do we have here is a left tail. Okay, so you have the tail goes off to the left hand side. Okay, left tail. The area of that tail is 0.2, and I know my standard deviation is 8, and my mean is 177. So when I execute on that, it'll give me 170.3 centimeters, or 0.27 centimeters, whatever you want. Just check that that's reasonable. Yep, it's below the mean. It's on the left hand side, sounds good. So I'd write some sentence such as I should make the minimum height 170 centimeters. That's one type of problem. We have another type of problem which is a center problem. So again, mean of 177, standard deviation of 8. Between what heights are the middle 50% of people? So between what heights, give them letters, say between C and D. What is C and D such that this area is 0.5? So again, you won't necessarily have that diagram for yourself, so you better draw one yourself. I'm after the probability that C is, correction, that X is between C and D to be 0.5. So again, graphics calculator, this is a lot easier than it was 10 years ago. I have a center area, which is 0.5, and my mean and standard deviation have stayed the same. Okay, so this will provide me with the range of heights. So C is 171.6, and D is 182.4. And again, write some sentence like the middle 50% are between those two values. The third type of problem is a right tail problem. Same mean, same standard deviation. So how high should we make a doorway so that only the tallest 5% of people have to duck their head when walking through it? Which means there's some value C here such that this area is 0.05. Again, we'll draw our own diagram. What we're trying to find is the value C such that the height being greater than C is 0.05. Again, to the calculator, we have this, in this case, a right tail, tailing off to the right. Its area is 0.05. Same mean, same standard deviation. I get a height of 190.16. Okay, so I need to make the doorway 190 centimeters high so that the tallest 5% only the tallest 5% duck their head. Okay, so hopefully you look at those three examples, you think, yep, left tail, center, right tail. I know how to calculate all those using my graphics calculator. So you can practice probably some of those earlier problems before we have a look at the problem solving question. Alright, so to do this problem, we'll need to use all our knowledge of normal distribution and standard normal distribution. So the standard deviation of a normal distribution is 16, and it's known that the probability of the variable being greater than 17 is 0.99. Find the mean. So I'll try and draw as much information as I can on here. So the mean, I don't know. Standard deviation is 16. And I know the probability of it being greater than 17 is 0.99. So I know that 0.99 greater than some value, my value must be over here somewhere, so that this shaded area can be 0.99. Okay, so I'll go to my graphics calculator, see if there's anything I can do. I've got a right distribution, its area is 0.99. Standard deviation is 17, but I don't know what the mean is, and I can't put a question mark in there. I can't solve for the mean, so I'm going to need to do something slightly different. So remember, this is a normal distribution. I'm going to need to problem solve using the standard normal distribution. So what I'm going to need to do is find, using my standard normal distribution with mean of 0 and standard deviation of 1, I'm going to see if I can find the z value. Correction. So these are x values. Find the z value, say c, such that this area is 0.99. So I'm trying to solve for p, probability that z is greater than c as 0.99. I can do that on my calculator. Okay, I've got a right distribution, standard deviation of 1, mean of 0. I can get a z value of minus 2.33. So c equals minus 2.33, which tells me that to get an area of 0.99, this c value needs to be minus 2.33 standard deviations from the mean. So what I'll be able to do is use this x value of 17, use this standard deviation of 16, and use this z value. So this is an x value, this is a z value, and combine them all into my standardization formula. So I'll have a z value of minus 2.33, x value of 17, and a standard deviation of 16. And I should be able to solve this equation and find that the mean is 54.28. So it really requires you to know what both distributions are about and be able to use it to problem solve. Okay, hopefully you'd set it out better than that. You'd probably have some words around there, tell a bit of a story, but that's the main idea of those sort of problem solving questions, really changing between the two distributions like I sort of had to 10 years ago when I first learnt this. Okay, so good luck with those problems.